There are, at this moment, exactly two American shipyards capable of building nuclear-powered warships: Newport News Shipbuilding in Virginia and the Portsmouth Naval Shipyard in Maine, the latter for maintenance and refueling, not new construction. For aircraft carriers and nuclear attack submarines, the United States is a single-yard nation. Newport News is the only facility on American soil where a nuclear-powered carrier can be built from keel to commissioning. This is not a new constraint. It is a structural condition that has existed since the Cold War consolidation of the American defense industrial base. What is new is the degree to which that single yard is operating at its physical limits, and the degree to which the supply chains feeding it have themselves contracted. The Congressional Budget Office's 2023 report on submarine production identified the specific bottleneck, not the yard itself, but the capacity of the two torpedo tube manufacturers and the single domestic producer of reactor-grade steel plate, a material specification so precise that it cannot be quickly sourced from outside the certified supplier network. The United States currently produces approximately 1.2 Virginia-class attack submarines per year. The stated requirement to maintain strategic parity, according to the Navy's Force Structure Assessment, is approximately 2.3 per year. That gap between 1 and 2 is not a procurement failure. It is a physical ceiling imposed by the industrial ecosystem beneath the yard. Brian Clark, Senior Fellow at the Hudson Institute and co-author of the 2021 analysis Restarting the Race, a blueprint for rebuilding America's naval industrial base, documented the workforce dimension of this constraint in detail. The average age of a skilled shipyard welder in the American naval industrial base is 54. The apprenticeship pipeline that would replace that workforce takes between 5 and 7 years to produce a journeyman certified on nuclear-rated systems. The workforce gap compounds. The production ceiling does not move. The AUKUS agreement, under which the United States and United Kingdom committed to help Australia acquire nuclear-powered attack submarines, was announced in September 2021. The first Australian submarine under that agreement, if timelines hold, is scheduled for delivery in the early 2040s. That gap is not political delay. It is the lead time imposed by the industrial reality of a single-yard, constrained pipeline ecosystem. What the United States has in concentration, Europe once had in distribution. Britain, France, Germany, Italy, Spain, and the Netherlands each maintained sovereign shipbuilding capacity through the Cold War, not as a collective strategy, but as a legacy of imperial naval competition that had simply never been fully wound down. What you have watched happen since 1991 is the systematic rationalization of that distributed capacity under the logic of post-Cold War defense economics. The argument was coherent as far as it went. Duplicative European naval capacity was expensive to maintain in peacetime and could be consolidated without strategic penalty because the threat environment no longer required it. The result is that most European NATO members now build either surface combatants or submarines, but not both, and several build neither at meaningful scale. France retains the most complete sovereign naval industrial ecosystem in Europe. DCNS, now Naval Group, operates yards at Cherbourg and Lorient capable of producing nuclear ballistic missile submarines, conventional submarines, and major surface combatants. This is not an accident. France deliberately maintained sovereign nuclear deterrent capacity across every industrial input, hull, propulsion, weapons, as a function of Gaullist strategic autonomy doctrine. The doctrine had costs. It also had consequences. France is the only European state that can, without American industrial participation, build a nuclear-armed submarine from scratch. Britain cannot. The AUKUS Astute-class attack submarine program, managed by BAE Systems at Barrow-in-Furness, the only submarine construction site in Britain, has taken an average of 11 years per boat, against an original estimate of 7. The Barrow facility is the sole British submarine yard. When the workforce at Barrow contracted in the 1990s, the institutional knowledge embedded in that workforce did not survive the reduction. The Astute program's delays are, in significant part, a consequence of a generation of skilled workers who retired or left the trade during the post-Cold War drawdown, and of the 2 decades it took to rebuild the pipeline. Germany, the largest economy in Europe, no longer builds any submarine for its own navy. The Type 212A boats, operated by the Bundesmarine, are assembled at ThyssenKrupp Marine Systems, but the program is perpetually undercrewed relative to German naval requirements. Italy's Fincantieri builds frigates and offshore patrol vessels of high quality, but does not sustain a nuclear-capable industrial line. Spain's Navantia produces the F-110 frigate and S-80 submarine, the latter delayed by more than a decade in part because an error in the weight calculation of the pressure hull went undetected until the submarine was structurally too heavy to dive safely. The point is not to catalogue failures. The point is to observe the structural reality. European naval industrial capacity, taken in aggregate, cannot replace its losses under wartime attrition at a rate that would matter within a 5-year conflict. That is the operational implication of 3 decades of post-Cold War rationalization. Here is what most Western coverage describes. China has dramatically expanded its navy. The People's Liberation Army Navy now fields more hulls than the United States Navy. Chinese shipyards have launched more warship tonnage in the past decade than any other nation. These facts are accurate. They are also, in isolation, somewhat misleading as strategic indicators, because they describe output without describing the ecosystem producing it. The more consequential reality, identified by Lyle Goldstein in Meeting China Halfway 2015, and expanded in subsequent work by the Center for Strategic and Budgetary Assessments, is not the fleet China has built. It is the dual-use shipbuilding infrastructure China has constructed over the same period, and the degree to which that infrastructure represents a structural advantage that Western navies have no near-term answer to. China operates 7 of the world's 10 largest shipyards by output. The Jiangnan Changxing shipbuilding complex outside Shanghai is, by most industrial metrics, the largest ship production facility ever constructed. It builds commercial tankers, container ships, and naval destroyers on adjacent slipways. This is not merely impressive scale. It is a strategic architecture. The commercial and naval industrial bases are deliberately integrated, meaning that in a surge scenario, the throughput capacity available to the People's Liberation Army Navy is a function of the entire Chinese commercial shipbuilding sector, not merely the designated naval yards. The United States has no equivalent. American commercial shipbuilding capacity has been structurally uncompetitive since the 1970s, when Jones Act economics and labor cost differentials drove commercial construction offshore. The American naval industrial base is a pure defense sector. It has no commercial base to draw on in a surge. When the Congressional Research Service estimated in 2022 that China could build 5 destroyers in the time it takes the United States to build 2, this was the structural explanation. China's naval surge capacity is backstopped by a commercial shipbuilding sector that is itself the largest in the world. America's is not backstopped by anything. Toshi Yoshihara, in Dragon Against the Sun 2020, made the precise strategic argument. China has not merely built a navy. It has built a naval industrial position that allows it to absorb losses in a conflict and continue producing at rates that would outpace American replacement capacity within 18 to 24 months of sustained high-intensity combat. Yoshihara's analysis remains the most systematic treatment of this asymmetry in the English language strategic literature. This is the refrain. The competition is not between two navies. It is between two industrial systems, and the industrial system comparison does not produce the same result as the fleet comparison. Beneath the shipyards is a more fundamental constraint. Warship construction requires steel that is not commercially produced at scale anywhere, outside a small number of facilities that serve defense contracts exclusively. In the United States, the primary supplier of naval-grade steel, a specification designated HY80 and HY100 for pressure hull applications, is a single domestic producer, AUKUS facility in Norfolk, Virginia. The AUKUS naval-grade steel is produced at a Sheffield facility that has changed ownership 3 times since 2010 and is currently operating below its design capacity. This matters for a reason that is rarely stated directly in mainstream coverage. If you destroy the yard, you can rebuild the yard. If you destroy the steel mill and the institutional knowledge embedded in its metallurgical workforce, you cannot rebuild it on a combat timeline. It took the United States approximately 8 years to recertify a second source for nuclear-grade reactor coolant pump components after the primary supplier went out of business in 2014. 8 years for a single component of a single system. The supply chain fragility underneath the visible shipyard layer is the least mapped dimension of this competition, and it is the dimension that would most immediately determine outcomes in a sustained conflict. Every warship is the visible output of a supply chain that extends back through propulsion systems, combat management software, radar arrays, sonar transducers, hull steel and fasteners, each produced by a specialized supplier, many of which are sole source. The 2022 White House report on supply chain vulnerabilities in the defense industrial base identified 14 sole source suppliers for components critical to Virginia-class submarine production. 14 companies, in some cases single facilities, without which American submarine construction stops. The same report identified no domestic alternative for several categories of rare earth elements used in electric propulsion motors, elements that, in 2022, were sourced from Chinese suppliers. You can appropriate money for shipbuilding quickly. Legislatures can do that in a single session. You cannot appropriate a skilled workforce. The certified welders, the nuclear systems technicians, the combat systems integrators, these are not produced by appropriation. They are produced by apprenticeship programs that run 5 to 7 years, by community college technical tracks that require sustained enrollment, and by career trajectories that are competing at every stage with higher compensation employment in adjacent industries. The American Shipbuilding Association reported in 2023 that the naval shipbuilding sector needs approximately 100,000 additional skilled workers by 2028 to meet existing contract requirements, not surge requirements, existing contracts. The pipeline currently in training is producing roughly 11,000 qualified workers per year across all naval industrial categories. This is not a funding problem that can be solved by increasing apprenticeship stipends. It is a demographic and institutional pipeline problem with a resolution timeline measured in decades. Roger Thompson, in Lessons Not Learned, the U.S. Navy Status Quo Culture 2007, documented the workforce erosion pattern with specific detail. After every post-war drawdown, the American defense industrial workforce contracts, taking with it not just headcount but institutional knowledge, the tacit, embodied expertise that does not transfer through technical manuals. Thompson's argument was that this pattern had repeated itself after Korea, after Vietnam, and after the Cold War, each time producing a longer reconstitution timeline than the one before. What he identified in 2007 has since been confirmed by the empirical evidence of the astute delays in Britain, the Virginia production gap in the United States, and the South Korean observation that it is now faster to train a shipyard workforce in Busan than to reconstitute one in Bath, Maine. South Korea is the detail most Western coverage omits. Hyundai Heavy Industries, Samsung Heavy Industries, and Hanwha Ocean, formerly Daewoo Shipbuilding, operate the world's most productive commercial shipyards, capable of producing over 1 million deadweight tons of commercial shipping per year. South Korea does not currently produce major combatants at the scale of the United States or China, but it possesses the industrial workforce, the steel supply chain, and the yard infrastructure that would allow rapid naval scale-up under the right political and strategic conditions. The AUKUS industrial calculus has quietly begun to recognize this. South Korean industrial partnership is being discussed as a potential element of both the Australian submarine program and American industrial surge planning. That conversation is real and ongoing, and it is happening because the parties involved understand that the American and British industrial bases alone cannot produce the output the strategic moment is beginning to require. The closest historical parallel to the current moment is not the Cold War naval competition between the United States and the Soviet Union. The structural analogy that historians of naval power keep returning to is the Anglo-German naval race of 1898 to 1914. Specifically, the moment in that race when Germany's industrial production capacity crossed Britain's, not in fleet size, but in the rate at which fleet size could be changed. Arthur Marder, in From the Dreadnought to Scapa Flow, 1961, traced the moment precisely. In 1905, Britain launched HMS Dreadnought and rendered every existing battleship in every navy obsolete in a single stroke. What Marder documented in careful archival detail was the Admiralty's subsequent recognition that the technological reset had, paradoxically, disadvantaged Britain, because Germany, starting from scratch in the new category, could build dreadnoughts without the conversion costs of an existing pre-dreadnought fleet, and because German industrial capacity had, by 1906, reached a rate of hull production that threatened to close the British numerical lead within a decade. Britain responded with the naval program of 1909. We want 8, and we won't wait, accelerating production through political mobilization. It worked, in the narrow sense that Britain maintained numerical superiority through 1914. But Marder's deeper observation is the one that carries forward. Britain won the production race through deliberate emergency mobilization before the conflict began. The mobilization was a choice made under political pressure in peacetime. If it had been delayed until 1912 or 1913, the industrial lead time for capital ship construction, approximately 2.5 to 3 years per vessel, would have meant the mobilization did not translate into hulls before the war started. The structural principle is this. In naval competition, the lag between the decision to produce and the production of a combat-capable asset is measured in years, not months. The United States, in 2024, is in approximately the position of Britain in 1908, aware of a narrowing industrial gap, possessing political will to address it, but facing a production timeline that means today's appropriations produce tomorrow's, or the next decade's, warships. The AUKUS submarine agreement is the most revealing single data point about the current state of Western naval industrial capacity, not because of what it promises to deliver, but because of what its timeline reveals about what is possible. The agreement was announced in September 2021. The framework calls for Australia to operate Virginia-class nuclear-powered attack submarines by the early 2030s, transitioning to a new trilateral SSN AUKUS design by the early 2040s. The early 2030s timeline involves rotational deployments of American and British submarines to Australian ports, not Australian crewed vessels, but American and British vessels temporarily based in Australia. The first Australian crewed nuclear submarine, under current projections, will not be operational until approximately 2040. That is 19 years from announcement to first operational Australian nuclear submarine. To put that in context, when the United States decided to build the first nuclear-powered submarine, USS Nautilus, it went from design concept to operational vessel in approximately 4 years, in 1951 to 1954, under wartime adjacent industrial and political conditions. The 19-year timeline is not the result of political hesitation or bureaucratic process alone. It reflects the actual industrial constraint. The American yard that would build or support these submarines is already at capacity. The British yard at Barrow is already behind on Astute. The workforce that would train Australian submariners does not yet exist, and the supply chains for critical components are already strained, serving existing programs. The AUKUS timeline is the industrial reality expressed as a schedule. James Acton of the Carnegie Endowment for International Peace published an analysis in 2022 noting that the SSN AUKUS design, the trilateral submarine class intended for the 2040s, did not yet have a final design, let alone a production contract. His central observation, that the agreement was, in industrial terms, a commitment to begin a process that would produce capability in a time frame longer than many of the threats it was designed to address are expected to mature. You have noticed the argument being made with increasing frequency that unmanned maritime systems represent a credible offset to the warship production gap. The argument is structurally correct in some dimensions and insufficient in others. It deserves precision. Unmanned surface and undersea vehicles, USVs and UVs, can perform specific naval missions: surveillance, mine countermeasures, submarine detection, and some strike functions, depending on the payload. Ukraine's use of maritime drones against Black Sea Fleet assets in 2022 and 2023 demonstrated that cheap, GPS-guided unmanned surface vehicles can impose real costs on major surface combatants operating in constrained littoral waters. That is a real capability. It is not a replacement for the power projection and sea control functions that carrier strike groups and nuclear submarine fleets are designed to perform. The more important observation is industrial. Unmanned maritime systems can be produced more quickly than crewed warships, from a more distributed industrial base, with a lower unit cost and a shorter workforce certification requirement. This is strategically significant. It creates an area denial and threat multiplication capacity that does not depend on the high-end shipbuilding ecosystem. A nation that cannot build aircraft carriers in adequate numbers can, potentially, produce sufficient maritime drone capacity to complicate an adversary's carrier strike group operations within its home waters. The limitation is range and persistence. Current USV designs optimized for strike missions have operational ranges measured in hundreds of miles, not thousands. They do not solve the problem of power projection across contested ocean distances. They solve a subset of the sea denial problem. For a nation in the strategic position of Australia, a continent requiring maritime approaches to be defended at distance, sea denial capacity is necessary but not sufficient. The warship production problem does not disappear beneath an unmanned offset. It is partially, but not completely, mitigated. Warship production is the visible metric. Warship maintenance is the variable that actually determines whether a fleet can sustain operations through an extended conflict, and it is the variable that receives almost no public strategic attention. A Nimitz-class carrier requires maintenance availability of approximately 1/3 of its operational life. The nuclear refueling complex for a carrier A midlife refueling and complex overhaul takes approximately 4 years and occurs only at Newport News. For the duration of that 4-year window, that carrier is non-deployable. When the United States Navy has 11 carriers, and each requires a 4-year overhaul once per 25 years of service life, the effective deployable carrier count at any given time is closer to 8 or 9 than 11. The United Kingdom had to send HMS Queen Elizabeth to an American yard, Norfolk Naval Station, for repairs in 2023 after it was discovered that a damaged propeller shaft could not be addressed by British maintenance infrastructure within the required timeline. Britain's largest warship, its only operational carrier, required American industrial support for a non-catastrophic repair. That is not a political statement about the Anglo-American alliance. It is a precise statement about the current limits of British naval maintenance capacity. The People's Liberation Army Navy does not yet face equivalent maintenance constraints for a simple reason: its fleet is new. The average hull age of the planned surface combatant fleet is approximately 7 years. Maintenance requirements scale with hull age. By the mid-2030s, as that fleet ages, China will face its own maintenance surge requirement, and it will face it with the largest naval dry dock capacity in the world, having built that capacity in anticipation. For 3 decades following the end of the Cold War, the United States and its allies made a rational decision in an irrational strategic environment. They treated naval shipbuilding as a procurement category to be optimized for cost efficiency rather than a strategic resource to be maintained for surge capacity. The logic was coherent given the threat environment of 1993 or 2002. It was made without adequate accounting for the lag between the decision to reconstitute and the reconstitution of capability. John Mearsheimer, in The Tragedy of Great Power Politics 2001, argued that great powers do not abandon competition. They defer it, disguise it, or misread the interval of deferral as a permanent condition. What the United States read as a permanent condition from 1991 to approximately 2015, the absence of a peer naval competitor, was, from the Chinese strategic perspective, an interval of industrial construction. China was not competing with the American Navy during those decades. It was building the infrastructure that would allow it to compete with the American Navy in the following decades. You watched China join the WTO in 2001. You watched Chinese shipyards absorb global commercial ship orders through the 2000s. You watched Chinese naval hull counts begin to climb steeply after 2010. What you were watching in sequence was commercial industrial base construction, dual-use integration, naval production scale-up. Each phase funded and enabled the next. The sequence was not hidden. It was visible in trade data and satellite imagery throughout. What was missing was not the information. What was missing was the strategic frame that made the sequence legible as a coherent industrial strategy, rather than a series of separate economic and military developments. That is the frame you now have. The competition for naval power is not primarily a competition between fleets. It is a competition between industrial ecosystems. The fleet you can see is the output of the ecosystem you cannot easily see, and the ecosystem comparison, held in that light, does not favor the same side as the simple hull count comparison. The structural logic of this moment demands a specific set of outcomes, not as speculation, but as the product of the industrial and strategic dynamics that are already in motion. The first is timeline compression pressure. The gap between stated American naval requirements and actual production capacity has become visible enough, and the political environment has become activated enough that significant additional industrial investment is now probable. The Naval Vessel Transfer Act provisions, the Shipyard Act, and the AUKUS industrial cooperation frameworks are all expressions of political recognition that the industrial base is the binding constraint. Whether those investments arrive at sufficient scale and sufficient speed is the remaining question. The trajectory is toward investment. The trajectory is not toward the capability itself, which requires years of production time that appropriations cannot shorten. The second is allied industrial reintegration. The degree to which Australia, Japan, South Korea, and the United Kingdom are being drawn into American naval industrial planning is without precedent in the post-Cold War period. Japan's Mitsubishi Heavy Industries and Kawasaki Shipbuilding Corporation maintain submarine-capable yards. South Korean industrial partnerships are being quietly structured. This is not alliance coordination for its own sake. It is recognition that the American industrial base alone cannot produce what the strategic moment is beginning to require, and that allied industrial capacity, properly integrated, might partially compensate. The third is the unmanned acceleration. The economics of unmanned maritime systems are favorable in ways that crude warship economics are not. Faster production, cheaper unit cost, more distributed supply chains, lower workforce certification requirements. Expect significant continued investment in autonomous systems as a partial offset to the crude warship gap, while understanding that offset as partial, not complete. The fourth, and the one most coverage does not reach, is the maintenance crisis that arrives as today's planned fleet ages. The Chinese naval industrial base is built for new construction. It has not yet been tested at the maintenance and sustainment demands of a mature, high operational tempo fleet. That test is coming in the 2030s. It is not a solution to Western production constraints. It is a complication in the Chinese trajectory that does not yet appear in most Western strategic assessments. What you've been watching is not a naval race. Naval races are competitions between fleets, between hulls, between tonnage, between missiles. What you have been watching is an industrial competition that expresses itself as a naval race, but whose outcome is determined not by what is in the water today, but by what can be produced tomorrow. The ecosystems that produce warships are not interchangeable. They are the product of specific industrial decisions, specific workforce pipelines, specific supply chains, and specific strategic commitments made over decades. You cannot rapidly reconstitute what takes decades to build. You can begin to reconstitute it. The timeline for that reconstitution is not a political timeline. It is an industrial one. Every future naval headline you read, every commissioning ceremony, every capability gap report, every alliance framework announcement sits on top of this industrial reality. Now you can read it. If you want more videos like this, subscribe.